Okay then, in this example we've got another type of area that we need to work out, and it's an area bounded between two curves. And here's an example here of one curve and another curve. We can let this curve be the y1 curve and this be the y2. The difference in the height now, if we want to sum this area up in here, will be that height will be the difference between the y values, won't it? So if we sum the y1 minus y2 and multiply that by dx, that will be the segment, rectangular segment, and we sum that between A and B. Suppose this point here is A on the curve somewhere, and this point here is B. I know I've drawn it as A is 0, but it could be anywhere. And that's how we work out the area of a curve, area between two curves. Don't forget we take the bigger from the smaller, so that we get a positive value. Okay, so here's our problem then. So the y equals x squared curve looks like this, and it goes that the other way as well. But the y equals square root x looks like that. So you can see this is y equals the square root of x, and this curve here is y equals x squared, and there's the area bounded by the curve, this segment here. So we know that they meet here and here. So we'll have to find out those points when the curves meet. So basically we need to solve the equation, when do the y values become the same? When does x squared equal square root x? Square both sides, x to the 4 is equal to x. And then move the x over, x to the 4 minus x equals 0. There's an x common. X, take it outside the bracket, and we get this equation when we factorized it, when we've taken out the factors. So here it tells us that this equals 0 when x is 0, and we get this value here, and the other one is when x cubed equals 1. If we cube root both sides, we get x equals 1. We don't get any other solution because a minus doesn't come out as 1, does it, when cubed? So it's just one other value, 1. So we can work out the area now then. So let's mark that as A. Area A is equal to the sum between 0 and 1 then, the difference between the y's. The upper y would be the square root value. The lower y would be the x squared curve. If you did it the wrong way around, then it would just come out as negative, and you could just change it at the end. So, oh, the area must be the other way up. So here, what have we got then? Is the integral between 0 and 1 of x to the half minus x squared dx. Now we can do the integration. Raise the power by 1, divide by that number, minus, raise the power by 1, divide by that number. So that's what we've got. And we're working out that integral between 0 and 1. This 2 that's underneath can be swung up to the top. So I'm going to do that here, rather than write a fresh line. So I'm going to put it in here now. So we've got top value, take bottom value, put 1 in. 120 power is still 1, so we've got 2/3. Minus 1 cubed is 1, so it's 1/3. Put 0 in. 0 to a power is still 0. 0 times number is 0. 0 cubed over 3 is still 0. 2/3 minus 1/3 is 1/3 units squared.